Welcome to the very first CMA 7th grade math informational video. This video is going to be for our first topic. Students should use the Cornell closed notes that are provided by the teacher while they watch the video, filling in the missing words. After filling in the missing information, students should write a question for each box or chunk of information that will help them to connect with the key concepts, term, or terms. The day after taking the notes and writing the questions, the student should answer each question using complete sentences in the summary section of the Cornell notes. For Module 1, Topic 1, we'll be talking about circles and ratios. The learning objectives. Students will be able to correctly identify the parts of a circle, understand the mathematical relationships that exist between the parts, and be able to reason through problems using given information to answer the question. The specific math standard that we are addressing is 7G4. Know the formulas for the area and circumference of a circle and use them to solve problems. Also, be able to give an informal derivation of the relationship between the circumference and area of a circle. Why we are learning this. Present culture uses circles in various ways. In the construction of buildings and parks, as the base for packaging products on a global scale, in the design of airplanes, cars, toys, and more. Our work toward understanding the mathematical properties of circles will benefit us, 1, by growing our understanding of proportionality, which is everywhere, and 2, by setting the foundation for working with equations, also known as algebra. How will we know if we are successful? We will know we have achieved the math standard if we can use the math vocab correctly, identify the parts of a circle using math notation, and use the equations to find the missing dimension. First, let's look at the parts of a circle. The outside of the circle is called the circumference. The circumference is the distance around the circle. So if this little car could drive all the way around the outside of this circle, one time around the outside of the circle would be the distance of the circumference. The midpoint of the circle is called the center, and we can label the center of the circle in order to identify it for others. I have labeled the center of this circle K, so we can refer to this particular circle as circle K. The line drawn from the center to the outer edge is called the radius. And we can label the center of the circle and the end point where the radius touches the outside of the circle in order to identify it for others. So I still have my midpoint, my center point is labeled K, and then I labeled this endpoint C. So we can refer to this as the radius line segment KC. And we're going to draw a straight line above the letters to indicate that it is a line segment, which means it is a straight line with a definite beginning and end. And this line ends and begins at K and C. The line drawn from one point on the outside edge of the circle through the center to the opposite edge of the circle is called the diameter. And the diameter cuts the circle in half. So this purple line here starts at one end, travels through the center, and then ends up on the other edge. Diameter. We can label the endpoints where the diameter touches the outside of the circle to identify it for others. So I have labeled the diameter endpoints shown here, A and B. So we can refer to that diameter as line segment AB. Now a line that connects one point on the outside edge of the circle and then goes straight over to the other side is called a chord. This chord is line segment YZ because I've labeled the endpoints Y and Z, and it's a straight line, so we have another straight line here. Special note, the line or the chord that passes from one side through the center to the other side is the diameter. So the diameter is just a special chord that goes through the center. Now the part of the circumference, so if we took a piece of the circumference, a piece of this outer edge, so that string, that orange string that goes all the way around, if we snipped it here at point Y and we snipped it here at point Z, what we would be measuring is called an arc. And we would identify that as arc YZ because those are our endpoints. And we're going to draw a little curvy line above the YZ because this is a curvy line here. So this is arc YZ. So to review the parts of a circle, we have a chord, we have the diameter, which we can represent with the letter D, we have the center, we have the radius, which we can represent with the letter R, we have an arc, which is a piece of the circumference, and then we have the entire circumference, which is the distance around, so this orange line. And we can represent that with, we usually use the capital letter C for circumference. And the reason these three are highlighted and given letters is because these three are in our equations that we'll be using. So our equations are based upon constant mathematical relationships. The radius and diameter have a constant multiplicative relationship. We have said that the radius of the circle is the distance from the center of the circle to a point on the outer edge of the circle. And we have said that the diameter of a circle is the distance from a point on the outer edge through the center and continuing to the opposite edge of the circle. We can conclude then that the diameter is in essence two radii, which is the plural of radius. So it's basically two radiuses, which we should call radii, laid end to end. And that, if we multiply the radius of a circle by 2, we can get the diameter. And that gives us this first equation in yellow here. Our diameter is equal to 2 times our radius. Inversely, if we divide the diameter by 2, we'll get the radius. So we get these two equations here. These both mean the same thing. This one says radius equals diameter divided by 2. This one says radius equals the diameter divided by 2. And since we have equations that relate our diameter and our radius, and that's all we have that might be unknown since we have only 2 letters here. If we're given one of the letters, we can easily find the other. So let's take a look at how that's done. Radius and diameter. Using the formulas, if you're given one, find the other. So if you're given radius, you can find diameter. If you're given diameter, you can find the radius. We're always going to use 4 steps. 4 steps when we work with equations. Step 1 is going to be write the equation. Because they give us R, they give us this one. This is the one we don't know. This is the one we know. We'll want to use this equation because what we don't know, we're used to having it on the left here. So D equals 2 times R. Step 1, write the equation. Step 2, we're going to show the substitution. I'm going to replace this letter R with the number 3 because they tell us that R equals 3. So now my equation says D equals 2 times 3. Step 3 is going to be evaluate or simplify or do the math. So 2 times 3 is 6. So I'm going to write 6. And now my equation says D equals 6. Now step 4, add units. This is very important. So since we started with inches, we are going to use inches down here. So our diameter is 6 inches. And this is super important because 6 inches is vastly different than 6 miles. Okay, so we always want to check. What are the units we're starting with? Make sure they match. If we're going the other way, if we're given the diameter and asked to find radius, we'll use this equation here. So everything on the right side, we know everything on the right side. They give us D. We know what 2 is. It doesn't need to be changed. So we have R equals D divided by 2. Step 2, show the substitution. Well, it tells D is 6, so we replace the D with a 6. Now our equation says R equals 6 divided by 2. Step 3, evaluate, simplify, do the math. 6 divided by 2 is 3. So now we have R equals 3. But that 3, it could be anything at this point. If you were to answer the radius is 3, Miss Rillema, I would say 3 what? 3 feet, 3 yards, 3 miles? Well, we're working with inches, so the radius here is 3 inches. Now for the interesting relationship, circumference and diameter. So it is also a constant multiplicative relationship, which means we're either going to multiply by something to get the other or divide by something to get the other. Multiplication and division are essentially the same operation. One is the inverse of the other, and we'll talk about that in a different lesson. But the reason this was exciting was because hundreds and hundreds of years ago, when they found out that the distance across the circle is always going to be um, the circumference of the circle divided by a certain number, it was quite impressive. And when you make that connection, that how can this always be true? It's pretty fantastic. So what we have is that each and every circle, no matter how big or how small, has a constant relationship between the distance around the circle or its circumference to the distance across the circle or its diameter. What we get from that are two equations from two different perspectives. So if we kind of go forward, we can multiply the diameter of a circle by 3.14 or pi to get the circumference. So that equation is circumference equals pi times diameter. Now, both this here, 3.14 and pi, have these little stars. And when you guys see those little stars when you're reading in a text, that means there might be something important either at the bottom of the page or at the end of the paragraph that will also be starred and be important. So when we come down here, we find our star. So in this kind of orangish pinkish box, it says pi is a Greek symbol, but it's also the symbol for the number that always results when we divide the distance around a circle, its circumference, by the distance across the circle, its diameter. And this number that always results, it's a little more than 3. So we could say that the circumference of a circle is always a little more than thrice or 3 times its diameter. Pi is actually an irrational number, which means it goes on forever. But we're not going to be able to use all those extra numbers, so we're going to round pi to 3.14. And because we round pi to 3.14, we're going to be changing our equals mark to an approximately equal to mark when we substitute this rounded version of pi, 3.14, in for pi. And that's what you see in this yellow box here. So it starts out, circumference is exactly equal to pi times the diameter. When we substitute or replace pi with this rounded number, 3.14, change that straight equals mark to an approximate equals to mark. So what it says now is the circumference is approximately equal to 3.14 times the diameter. Now the inverse relationship, so if we're working from the other direction, if we divide the circumference by pi, we'll get the diameter. So that equation is here. The diameter is exactly equal to the circumference divided by pi. And when we replace pi with 3.14, or we substitute in, then we change that to approximately equals to, and the equation we have is d is approximately equal to the circumference divided by 3.14. Again, just like with diameter and radius, we end up with equations where we have two letters that are related to each other, and then there's a constant number. And it's tricky because pi doesn't look like a constant number until we actually substitute 3.14 in, but we always know what pi is. So really, we've got two dimensions that relate to each other, and given one, we can find the other. So let's take a look at how that works. Circumference and diameter. So we have on the left, if we're given the diameter and asked to find the circumference. On the right, if we're given the circumference and asked to find the diameter. Step one is always going to be write the equation. Since we're given d and want to find c, we'll use this equation. C equals pi times d. When we substitute in step 2, 3.14, change that to the approximately equals to mark. Substitute in 6 for the diameter because it's given. Then we're going to do the math or evaluate, and we come up with 18 and 84 hundredths. When we add units, we just go to the beginning of the problem. Oh, it's inches, so we add inches here at the bottom. If we come from the opposite direction, if they give us the circumference and we're asked to find diameter, we can write this equation instead. We don't know d, but we know c, and we know pi. So we're going to substitute in 18 and 84 hundredths and 3.14, which means we change that equals mark to approximately equals to. When we do the math, we get 6. When we add our units, our conclusion is the diameter is approximately 6 inches. Circumference and radius is another constant multiplicative relationship. Since we have stated that the circumference is pi times d and that d equals 2 times r, we can substitute 2 times r in for d to get this next equation, c equals pi times 2 times r. So all I've done is substitute or replace this d with 2 times r because they are equivalent. They have the same value. And because the order of multiplication does not matter by the commutative property of mathematics, instead of writing c equals pi times 2 times r, I can also write c equals 2 times pi times r. And this is the equation that you'll probably see more frequently when we have c and r in an equation. This is sort of the standard way people write it, but I wanted to introduce it to you this way because it shows the substitution of 2 times r in for d, and then we can rearrange those factors any way we want and we get 2 pi r. When we substitute in, becomes approximately equals to 2 times 3.14 times the radius. So if you're given the radius and asked to find circumference, you can use this above equation. The inverse approach, if you're given the circumference and asked to find the radius, we can use this equation below. R equals C divided by 2 pi, or R is approximately equal to C divided by 2 times 3.14. Using the formulas, given one, find the other. So if we are given the radius, asked to find the circumference, this is the equation we will write. We'll show the substitution. They give us 3 for r. We're going to use 3.14 for pi, so we change that equals to approximately equals. We do this math, and we get 18 and 84 hundredths. We're going to add our units, which are still inches, and we have the circumference is approximately equal to 18 and 84 hundredths inches. If we're coming from the other direction, if they give us circumference and ask us to find r, we'll use this equation because we know c, we know pi, what we don't know is the r. We'll show the substitution, change equals to approximately equals to, and here is a little bit of a tricky part right here. If you guys are using calculators, you might come up with the wrong answer unless you make sure to indicate or actually do this multiplication in the denominator first. Because 18 and 84 hundredths has this line all the way across and all this stuff is down here. That means that this number up here needs to be divided by all of this. And sometimes when you guys type it into the calculator, you end up dividing by 2 and then multiplying the result by 3.14, which is not going to get you the right answer. So what I've shown is this kind of intermediate step. This gets done first. So we get that 6.28. 2 times 3.14 gets us 6.28. Then we can take this number and divide by that value, and we get 3. And we're going to add our units, which are still inches, and that's radius equals to 3 inches. Now, when we add a second dimension, we get a more complicated mathematical relationship, but we still have an equation to help us out, so we'll be okay. Area is special. Remember that area is measured in square units, whereas length is measured in just straight up units to the first power. So here we have radius. Radius is a linear measurement. It means it's a straight line, and we just measure, just like measuring how tall you are. We don't measure how wide you are, just how tall you are, just one dimension up. So radius is one straight line linear measurement. An example, 3 centimeters, 2 inches, 4 and 3/10 miles. Diameter, also just a straight line, a linear measurement. Examples, 6 centimeters, 4 inches, 8 and 6/10 miles. Circumference is also a linear measurement because if we took a string around the circle and then snipped it, we could straighten that string out and measure it as a straight line. That car that's going to drive around the outside edge will feel like it's driving a straight line. The distance is linear. So examples are 18 and 84 hundredths of a centimeter, 12 and 56 hundredths of an inch, 27 and 4 thousandths of a mile. Those are all linear. Now, area is not a linear measurement. Remember, area is measured in square units, so 5 square centimeters, 11 square inches, 50 square miles. You guys have learned these area formulas for rectangle. It's length times width. So if you're given a length of 6 and a width of 3, we get 6 times 3. And our result is 18. And because it's inches and inches, we get inches squared. So the area of the rectangle is 18 square inches. The area of this triangle, we can use 1/2 times length times width. We would get 1/2 times 6 times 3, which gives us 9 square inches. With circles, we have radius, which is linear, diameter, which is linear, circumference, which is also linear. When we go to area, we have a special formula to use, and that's here in this yellow box. The area of a circle is equal to pi times r squared. Now, r squared is not 2 times r. R squared means r times r. So instead of writing this top one, you might always just want to write this one. Area equals pi times r times r. Then when we show the substitution, 3.14, so we change the straight equals mark to the wavy. And then we can show I'm going to take 3.14 times 3, and then I'm going to do times 3 again. And the answer that I get is the area of this circle is approximately 28 and 26 hundredths square inches. Now let's take a look at going from one way to the other. So area and radius, using the formulas, given one, find the other. Now when we're given radius, finding area is fairly straightforward. You'll write the equation, either a equals pi times r squared, or you could write this one, a equals pi times r times r. You're going to show the substitution, then you're going to do the math, then you're going to add the units. So we get, for a radius of 3, area is approximately equal to 28 and 26 hundredths square inches. Now this way, this inverse, when we go from area to find radius, looks a little funky, but we will be practicing how to do this. So our step one is still going to be write the equation. If we want to find r, well, r is equal to the square root of the area divided by pi. So when I substitute in, they've given me area. So I got 28.26 in the numerator. And then I'm going to divide by 3.14, substituted for pi. Since I rounded pi, I'm going to change that equals to approximate. Then I'm going to evaluate. And I'll want to do this stuff inside first. And when I divide 28.26 by 3.14, I get 9. And then I can use the square root key on my calculator to find out that the square root of 9 is 3. And then I'll add my units. So the radius is approximately 3 inches. And we will be practicing these guys. So no worries, no hurry. We will get them down. And that is actually the end of our circle relationships that we're going to be working with. So in conclusion, the math magic of circles, there are mathematical relationships between the various dimensions, the radius, the diameter, the circumference, and the area. And what we're going to be doing is using the equations in a systematic step-by-step way to solve for the missing dimensions using the information given and the equations. And in our yellow box, this is our go-to step-by-step. Step 1, you're always going to write the equation. Step 2, you're always going to show the substitution. Step 3, you'll show me what came out of there when you did the math. And step 4, you're going to add the units. I think that if we go forward with this systematically, step by step, we are all going to be successful and happy.